Just giving you an idea of how you're doing in kind of a quiz scenario for your quiz next week, your real assessment next week. And this, of course, was just on the first section, which was the end behavior and graphing, well, light graphing, and then polynomial operations that include adding, subtracting, and multiplying. I'm going to start on this page, and that's weird. No way, it's like mirroring something from yesterday's work. I haven't even opened today. That is weird. Technology. It is. Never again. All right, number one, you should have chosen C. And the big idea there is that our leading term was at the end of this one. In other words, it wasn't in standard form. So 2x to the fifth. And did it show up weird on yours like this right here? Or is it normal on yours? Okay. Obviously, this should be exponents, but... So just as a quick review, what would the end behavior look like on that one? Just do your arms. We should make some kind of a dance. Everybody good at that? Choreography? We should make a dance. Anyway, so it should be this one, right? Positive, odd. Something like this. All right. If they got it wrong, mark it. And this is worth 1 point, so just out to the side, like if they got it wrong, put -1.
Do you lose the point if you didn't write as x goes to infinity?
Okay, on number 2, yeah, if you didn't write this, the whole problem is wrong. You get no credit, okay? That one is worth 2.
It says select all but apply, but it's not a multiple choice question.
Oh, I thought I took that off. See, it's not on mine.
It's very much on ours.
There also isn't.
Oh well. All right, number 3. This is worth 1. Let me talk you through this one. It's mine are again in a weird format. It's because it's a PDF and it didn't print right. But it says use the zeros and turning points. Well, I think that's a little bit misleading because the better idea is to use the end behavior and the y-intercept for this one. Okay. So first thing, note that I scratched this one off because it has negative end behavior. And this one has both ends pointing up, so it isn't negative. So B is out right away. C has odd end behavior, which would be this way. And obviously it's not that, so scratch off C right away. And now we're down to D and A. Both are x to the 4th, which this could be. And for that, you could use your turning points, right? It has 3 turns, and so potentially a 4th degree. But to distinguish between those, we need the y-intercept. And remember, for y-intercept, we set x equal to 0. And what that does is eliminates those 2 terms and just leaves 4 and -16, which clearly it's not -16. And so that's how you end up with D. Okay? Any questions on that one? It's interesting because with polynomials, they're kind of intimidating looking sometimes, especially if they have like 7 terms. Let's say it's a 6th degree polynomial. But if I say find the y-intercept, like we don't care because all we have to do is just scribble out everything that has an x. And the leftover piece is your y-intercept. All right, number 4. 2 on that one, 2 points. Here's what I'm looking for. The zeros need to be correct. And we find those zeros by figuring out or being told where it crosses from positive to negative and vice versa. So negative, wherever it changes, that's a 0. That's where it crosses the x-axis and changes sign. So those need to be in the right place. And then, I don't know if you can see this color, but those light blue are where it changes from increasing to decreasing or vice versa. those you don't necessarily need to mark, but just know that that's where it should turn. That's your turning points. So on this one for the 2 points, we need the correct end behavior and roughly the correct places where it was positive and negative. Okay? And be nice, like if they are fairly close, give them 2 points. If they got the wrong end behavior, give them 1, I guess. Okay? Do you guys have this question, or did I print it weird too?
No, we have.
Okay, it went on a different page for me. All right, so again, the y-intercept, it's cool. On these, even if they're nasty looking like this one, anytime you plug in x equals 0, if this is 0, this whole thing is 0, this whole thing is 0, and we're just left with 2. Okay? So 2 is our y-intercept. It represents how much water is in the tank at t equals 0, or at the beginning of our filling up. Okay, that's 2 points. They need 1 point for the y-intercept and 1 for the description.
The description is the amount of water in the tank, either in general or
Yeah, that sounds good. All right, next page. So these ones we're just adding, subtracting, or multiplying. So negative 2a squared b plus 2ab plus 5 on that first one. I'll just leave it up here for a second while you look. Do a half a point per term, meaning like half point, half point, half point. So if the term's wrong, or if they have an extra term, just mark it off, take off half point.
or if they missed a sign.
Sign would be counted as part of the term. So if a sign is wrong, that term is wrong. Okay. This one will be worth 2. Half point per term. Next one, I'll just leave them up here for a second while you check. Again, half point per term on number 3. And the sign is included with it.
So if they added an extra term at the end,
Take off half. Yeah. If they added an extra term, take off a half. Any questions on those for grading? Yeah.
What is it in standard form?
Oh, yeah, okay. So, are you talking about any of them or just 3?
Just 3.
So, I wrote this in a typical standard form. And remember, the xy term should come after any of these that have higher exponents. If we take the entire power, if you want to say it that way, of this term, it would be 2 plus 1 is 3, and then 1 plus 2, that's also 3, and then 2 and 2. Anyway, I haven't mentioned it for these mixed variable kind, so don't take off points for that if it's not in standard form. I mean, the x cubed term should be first. But, all right, and then finally, I'll try to leave this one up here, but 2 points on this one. We need an expression for the perimeter and some work, and then a point for their answer. Okay? So 1 point, for a total of 2. If they do a picture, it's fine, but this still needs to be there. I mean, if it's something like this, and they like wrote, around, I don't know. The picture is not part of the math. It's part of the thinking, but not part of the math.
So 1 point is for them writing P equals to 1.
Yeah, I'll just do it like this. 1 point for the work, 1 point for how it went, like their solution. Okay. That's going to make it look like that's worth 4. Let me fix that. 1 here, 1 here. All right. So this page is worth 4, 6, 8. Don't circle it. And 8. So this is 16. Go ahead and put the total out of 16, please. Total correct out of 16. Yep, total correct out of 16. Once you have that, go take it back to whoever's you have. Once you've seen yours, go ahead and bring it up to the bin, please.
Is number 1 on the other side?
Well,
How many times?
which side? That side? That was 1.5 because it was 3 terms. Hi, Chantel. Here. Did you make a mess? Did you make a mess?
I'm so confused.
Yep. Once you've seen yours, go ahead and bring it to the bin. Up here, please. And then go ahead and grab your homework and your notes and all that stuff.
For this one, I turned it in on Classroom, but it says it's missing on.
Okay. Did you turn it in late? Okay. Will you remind me at the end?
Yeah.
How'd it go? Okay.
Yes, it was. Look.
Yeah, just bring it up.
Oh my god.
So we're given a polynomial, but it's in factored form. Which, by the way, by the end of the unit, this is how we will be working with polynomials, is in factored form. And the work we do today on division is going to get us going on that track to being able to write it in this form. So think about if we expanded this whole thing out, what would the degree be? So I have an x cubed, x squared, and x to the first. Now, if we expand it all out, like this term is going to be x times 1 3 times. This will be x minus 2 3 times. And it's going to have a lot of terms. It's going to be kind of nasty. But just for the degree, for the first term, remember we can just look at the powers of the x's. So x cubed, x squared, x to the first. What do those add up to? 6, right? So x cubed, x squared, and x to the first. That we add the exponents and we get 6. So we get a 6th degree. Okay, for the lead coefficient, we just need to keep track of sign. So here's what I mean. Now we're just looking at stuff in front of x, knowing that we have to be careful with the sign. So -3 and then x cubed, this is going to be just whatever the sign is, that's what it's going to have, okay? So this is negative, and then here this is positive. Even if it was negative, it would be negative times negative because it's squared, so it would be positive anyway. And then here that's positive as well. So it's negative times positive, which is what? I'll write it like this. Negative times positive times positive. What does that give you? Just, who cares what the number is? Remember, all we care about is the sign. That's negative, yep. Okay, so we have negative even in terms of our degree. So negative even. Use your arm, show me what the end behavior looks like for negative even. Negative even. Right? Both down? So even before we know a whole lot of other things, we know it's going to be, let's do a better job on that. It's going to be like this. Okay? We'll connect some stuff in between there, but we know it's going to look like that. Okay, y-intercepts. Well, we do the same thing anytime we want a y-intercept, which is what? Set x equal to 0. Okay? Look what I'm going to do on this. And you can do this like with your pencil tip or your fingers. Just cover it up. I know you guys can't just hit like undo, but just for our sake. That means these x's are all zeros. That means I just multiply what's left. Okay? So 1 cubed is what? That's just 1. What's -2 squared? That's 4. So just underneath here, I'm going to say that's 1, that's 4. Okay? So it's -3 times 1, which is -3, times 4, -12, right? -3 times 4 is -12, times 4, -48. -48. Okay, so our y-intercept, guys, don't make the y-intercept hard. Don't make the y-intercept hard, it's just multiplying. Just be careful. Okay? Now notice I'm not putting any scale on this graph, and it's because sometimes these go way down there, and you don't want to be counting by ones down to 150 or something, okay? So these are going to be relative scale graphs. All right, what are the zeros of this? It's just where each term becomes 0, just like when we factored quadratics. It's the same idea. We just have more of them. So can -3 ever be 0? No, it won't, right? Can this term be 0, x plus 1? At -1. Yeah, so if we show this, x plus 1 equals 0 when x equals -1. So there's one of our zeros. Okay, can x minus 2 be 0? Yeah, at x equals 2. And then can x plus 4 equal 0? When? At -4. Okay, so let's go plot those on our x-axis. So we have, and again, the x-axis is okay to scale normally by ones because it's not ever going to be way out there. So we have one at -1, we have one at 2, and we have one at -4. Okay. This graph is going to look like this. It's going to come up through that one. It's going to snake. I did it wrong. We're going to learn this next week. It's going to snake through that one. It's going to bounce off that one and come down. Okay? So when we learn something called multiplicity of zeros, it's going to tell us how it looks as it touches each zero. This one is linear. That one is cubic. It passes through like a cubic function. That one is quadratic, so it bounces off. Okay? Now, if you didn't get all the bounces and the turns, that's fine. But at this point, I would expect, at a minimum, a graph that maybe looks something like this. Okay? At a minimum at this point. Just so we're hitting all the zeros at least. So how'd that go? This is a preview. Okay, preview of what the end of the unit exam and expectations will be, is being able to do this with this not being given to you. You'll have to find that, which will be about a 5 to 10 minute process of finding those zeros, okay? And it's division, and that's what we're about to start doing right now. So any questions before we do? Okay. This is like the end of the problem process once we've found all the zeros. All right, that said, grab your problem from in your notes where we started the long division. And we're going to do a couple different ones of these. Quick reminder. Our long division cycle is divide, multiply, subtract, and then bring down the next term. In polynomial long division, we're only asking how many times this first piece, it's always going to be some version of x. Maybe it's x squared, x cubed, but how many times does it go in? That's the only thing we're going to ask. We don't care about the rest of it. In fact, let's make a note of that right now. So only check how many times this goes in. Don't worry about the 3 in this case. Now you have this already down. I'm going to start over just to remind you. So don't erase yours, but follow along. That way we get back up to speed. Okay, so the first question was over here. How many times does x go into x cubed? And for that, I want you to do this. This isn't just for notes, but off to the left, I want you to write x cubed over x. Like write it as a over instead of division. Okay? Guys, just to remind you that rules of exponents say if you're dividing, you subtract exponents. So this is 3 minus 1, and that gives us x squared. Okay? Put whatever your result is, put it above the same power term. So we wrote it above x squared that time. That was the division step. Now we're multiplying. So x times x squared is our x cubed. So x times x squared. Now we do 3 times x squared. And that's plus 3x squared underneath the same power term. That's the multiplication. Now we're doing the subtraction. We just subtract vertically. So x cubed minus x cubed. That first term should always go away if you do it correctly. This first one should always be 0. And then 5 minus 3 is 2, and that's 2x squared. Now we're ready to bring down the next term, so plus 6x. Okay, and that completes the cycle. And we start over. Okay, so second round, what's our question? To start over again with division. What's our question now? Let's change color. Yeah. Yep. Obviously, you won't be writing the question off to the side, but I'm doing it for notes so you can go back and look. How many times does x go into x squared? Okay, again, off to the left. X squared over x. I just told you that when you divide, you subtract exponents. So what is x squared over x? It's just x, okay? We put that x above the same power over here. So plus x, it goes above the x term. Okay, that's division. Now we multiply. By the way, I didn't think about this till just now. It's 2x squared, not just x squared. Okay? So x squared divided by x is x. Sorry about that. But we need a 2 in front of it, don't we? In order to match? Sorry, Anthony, you were close to right there. Okay, so 2x squared, that's our next term. 2x squared divided by x is 2x. Put your 2x up above. Now we multiply. What is x times 2x? 2x squared. What is 3 times 2x? 6x. And the multiplication step is done. Now we subtract. And of course on this we get completely 0. Okay? And you can think about bringing down the 9. And it would just be plus 9. Does x go into 9? No. So that's the end of this one. That's the end. But do you guys remember? I'm going to write it and see if you remember this. Do you remember writing, like, let's say your answer was 5r2 and you had like remainder 2, okay? We're not going to write it with the r, but we aren't going to keep dividing either. We're not going to, remember I told you we're not going to put a decimal and keep going. So we are going to stop and just say what the remainder is. Okay? So this one, our answer, we're done dividing. Let me just make that clear. Let's make note that this is our remainder. Can you see? Okay. So our results there's a couple ways that we can do this. Let me pause here and just remind you of something. Let's say I'm dividing 25 by 10. Let's just see if you remember this. How many times does 10 go into 25? 2, and I would say 10 times 2 is 20, and then subtract, and I would get 5. So do you remember that this is 2? That's your quotient, your answer. And then 5 out of 10. The remainder is out of your divisor. So it would be like 2 5/10. Does that ring a bell at all? If not, that's okay. So we're going to do a similar thing with this, only it's just busier because of our polynomials. So our answer is x squared plus 2x. That's the quotient. And then we have 9 over x plus 3. And that's our remainder. Okay, let's do another one. You can put it in your note packet or just write it somewhere else. It's up to you, but don't put your notes away because I want to go back and add something to it after you see this example. Just a little cautionary step. So don't write all the words, just put this. Actually, don't even write the p of x. Just say that in your notes, please. Just put 8x cubed plus 27 divided by 2x plus 3. That way it saves you some writing. This, of course, I'll post, and if you need to go back and look at it. Which one goes on the inside? Yep, the first term. So let's go ahead and set that up. Now, before you do, don't just set up your division, because this is that caution that we need to go right after I show you this one. Do you see how we're skipping some terms between x cubed and 27? And that's okay for a polynomial, but not when we divide. So if we skip terms when we fill out our division, when we set it up, we've got to put them in there. And here's how. So I'll write it in your notes. Let me just show you it here. So it's okay to write the 8x cubed, but we cannot leave the next couple terms blank. So we're going to say plus 0x squared plus 0x. So it's like a placeholder, okay? Put a 0 because they're not actually existing, but we need them for a placeholder. Okay, and then your 27 goes at the end. If this was fourth, we would have to do 0x cubed, 0x squared, 0x. So anything that's skipped, make sure to put in there. That is also true if there's a term skipped out front. In this case, we're fine, but if there's a term out front that's skipped, we have to do that too. Okay. If it helps, write the process over here in symbols off to the side, just to remind you. So the first question is what in this one? How many times does what was it? Yep, it's just these first two terms. Okay, we're just saying how many times does 2x go into 8x? So I'm going to say round one. Actually, I'll just write that word. Is 8x cubed divided by 2x. So just divide the numbers and the letters separately. So 8 divided by 2 is 4. X cubed divided by x is x squared. Okay, that goes up here above the x squared, since it's an x squared term. That's the division. Now we multiply. Okay, so we're taking 2x and 3 times 4x squared. Okay, what's 2x times 4x squared? That is 8x cubed. What is 3 times 4x squared? 12x squared. Okay, and it's lining up nicely with the terms that we filled in. Okay, next step is to subtract. Make sure you make that stand out. Like you got to be able to see that you're subtracting. First term goes away. What is 0 minus 12x squared? Negative 12x squared. Good. And now we bring down 0x. Okay. That's round one. Let's do round two. What's the question this time? Yeah, good job for catching the negative. So it's negative 12x squared divided by 2x. How many times does 2x go into negative 12x squared? Okay. numbers and letters separate. Negative 12 divided by 2. Negative 6. X squared divided by x. Just x. Okay, we write that with the sign up here above the x term. So negative 6x. That's the division. Now we multiply all the way over. So 2x times negative 6x. Negative 12x squared. 3 times negative 6x. Negative 18x. Good? Okay, make your subtraction obvious. Negative 12 minus negative 12 is 0. 0 minus negative 18, positive 18. So that's, be careful with those negatives. Okay, and then we bring down 27. Round 2 is complete. Okay, let's do round 3. What's the question this time? Awesome. 18x divided by 2x, or how many times does it go in? Okay, 18 divided by 2 is 9. X divided by x is just 1, so we're not going to write it, okay? In other words, the x's cancel. Okay, so that single number, no x, goes above the single number in our polynomial. Now we multiply all the way over. 2x times 9 is 18x. 3 times 9 is 27. And now we subtract. And we get 0. What does that mean? We have no remainder. Okay? It turns out this is going to mean a lot more than that. In a good way. Like, it's a really, like, we're really happy when this happens. And the reason why is because it means that this answer is a factor of this polynomial. Which means that tells us that we're breaking it down, being able to find the zeros now. Okay? Actually, I said it wrong. It means this is a factor. It also means that this will be able to just factor. You know, it's a quadratic, so we can just use factoring potentially. Okay, so we just found a 0 of this polynomial. That is not always going to happen, like you saw in the first example. But what is the 0 of this factor? If I said go plot this, think of it like this. If we said what is the 0, that means find the 0. What would you say? Negative 3 over 2. Yeah, good. We're going to have a whole theorem on this, but let's just write it for now. Okay, because you'll see eventually, probably partway through next week, our goal is to break these big ugly things down so we can see them in factored form and see those zeros. We just did that in this case. All right, any questions on that? It's not too bad, right? If you just go slow and take steps, it's not horrible. On your notes or wherever you want to write this, let's go make sure that you put the note about if terms are skipped. So if terms are skipped in the divisor or dividend, that's the inside. Okay, I'll put a little example, but go ahead and write that. I'll write underneath there. I'll just show what I mean by that. Okay, if you're given 4x to the fourth plus 2x, we're going to use 4x to the fourth plus 0x to the third plus 0x squared plus 2x. And you don't necessarily need to write the 0 at the end, but do it. I think it will help you make less mistakes. Okay, so we filled in 0x cubed, 0x squared, and the 0 at the end. All right, let's use the rest of the time to do some practice. I'll tell you which ones on this.